All right, we created our CLI structure to start working with DSPy. Want to be productive, and a CLI to me is the best way to start. Like, I either have to start with a CLI, start with a website, or some kind of interface in order to interact with what I'm working on. I can't just be calling a CLI file. I can't just be calling the Python file directly. That kind of stuff, like incremental. So starting with a CLI. The cookie cutter that we used also has an API, which we'll use in a little bit later, but we're good to start. So now we have our, we're going to call it a new command. We're going to call it JSON. We're going to call it Pydantic, PYD, and then we're calling it I don't know, unstructured. We'll just call it text. There we go. So we have our PYD command, and we have a text. So let's change it to our documentation, which is convert unstructured text into Pydantic model. Perfect. All right, cool. So let's make sure we have Pydantic, which we should. Poetry add Pydantic. Cool, we already got it. And we got 2.73, perfect. All right, so we are going to create a class, hello world, or we're not going to do stupid or not trivial ones. So what's a traditional problem people have? We want to have a let's say that we're taking something that makes appointments. Yeah, we'll make appointments. So we have appointment. So actually what we're going to do is we're going to use cursor for this. So what we're going to do is we're going to say create a Pydantic class that represents an appointment in the iCalendar standard. Oh, it didn't. So there, we had to do it that way. Oh, wait. Okay, so it didn't like that. So we're going to clip that. We're going to first do this. Create an appointment Pydantic model from the RFC 5545 standard. Perfect. Okay, perfect. Right? This is oh shit. Keep. Yes. All right, perfect. So we're going to take this, we're going to put it up here. Okay. So we got that down. All of that's good. We got our example in there. Okay, and let's now go to, we got to add DSPy. So the way we can do that is we look up DSPy here. Excuse me. It's DSPy AI. Somebody, I guess, grabbed the other version. So we do poetry add DSPy AI. Okay. Now we're going to, from DSPygen, import, we're going to just take my init function, init OL. Okay. So we're just going to take this because I don't want to have to rewrite it. So, so just so you guys know what it's doing is we have a model that uses the DSPy OpenAI model or the Ollama model and takes the keys and does some stuff like that. So it just makes it faster. So we just pop that in our utils, and then we're good. All right, cool. So we got that to work with now, and we'll see if I remember to add it to my stuff, because that's always what I'm forgetting. So what we have now is, we got rid of type. That's what it was. Cool. We got our typer. So now we got a command. So now we can typer echo, but you can also just print. So we can do print, and then we can do appointment.json schema JSON. And I think that's a function. Yeah. Okay. So it's a function. And we'll make it indent too. Why not? All right. And then we'll do a new line. All right. Cool. So we got our JSON schema. I think if we don't have an indent, though, it's just without spaces. So let's now do our fun. Our command is pyd text. Perfect. Yeah. Okay. So it doesn't do. So yeah, something valid keys configs have changed. Oh, renamed to JSON schema extra. Wait. Okay. So this is just garbage. So we're just gonna have to deal with the noise. But anyway, here is our Pydantic, our JSON schema of our model, right? So what we're gonna do is we're gonna init Olama. Import this name, and we're going to use DSPy.predict. It's text, and we're just going to keep it simple, and we're going to do JSON schema, and we're going to call it like valid JSON for text, right? Like that's kind of how I envision these things. So then we do, I think the convention is pred. So then we do text. We'll just say a response is one way to do it. Pred, and you can do forward, right? And then we have to have text equals dentist at 5 p.m. right? And then appointment dot schema JSON. Oh, we have to do JSON schema equals that. And then to get the response at the end, we have to do dot this to get the response. And so then we print the response. And let's see what we get. Okay, perfect. So what it returned to us is the schema. Thank you very much. Oh, no, here it is. Perfect. Oh, we printed the schema. So actually, sorry. So it's we'll print initialize llama, and then we init ol, and then okay. So then we look at what we got back. So we're using the I chose the phi model to be the default. I liked the way it handles JSON better than llama 3, but let's just look at what it does. So we'll erase this. This is why we keep seeing this pop up. So we're going to just delete this now that the thing's being imported, just in case people were wondering. So we'll run it again. Okay. Cool. So you saw how fast it is. So you can see that, all right, does not directly relate to the dentist, right? Since there's no specific field, we cannot produce valid, right? Okay, so now we need to be able to provide, we can mess around with this, right? Or we can go to a signature, right? So what we're going to do is we're going to go to, well, we'll try now, let's try a chain of thought, right? Chain of thought. And you'll see that I don't know how well other models handle the way that this is. Okay, so actually, look, this looks pretty good. So I was wrong. Like, some of the information I have is wrong. So let's look to see if this works. So we got UID, date stamp, start, summary. We don't have an end, but it's optional. So we have a summary, we have a description, location, organizer, attendee. So this actually looks like valid JSON. So let's now do, we'll comment this out. We'll keep it just in case we need it in the future. We'll do print appointment dot model validate JSON response, and let's give it a new line at the bottom, and we'll run it. Perfect. All right, done. We now have a CLI that, oh yeah, victory lap, that's what we used to do. Not used to do, it's just pretty rare these days. Just not rare.
Nice.
But so that's how easy it is. So that's why when I see people like talking about like, oh, prompting and stuff like that, it's like, you probably just want this. We didn't even have to do a signature. So this was a phi model. So now let's create a little bit of a, we'll add my agents and stuff. So we'll add DSPy gen. Well, no, I mean, I think this is good for now. Do you guys have any other ideas of what you want to see add to this?
God, my use application is like super deep into like knowledge graphs.
Okay.
So, I had like bumped into a wall, essentially trying to figure out how to use DSPy to essentially like iterate over a chunk of text.
Yeah.
And go through that text, try to use the Bayesian optimization method to determine creating cipher statements, but also iteratively running through that text to break down the data into smaller and smaller metadata. So if you picture, for example, taking a chunk of text that mentions, for example, like a place, and then any things that might be associated with that place, also adding cipher statements for that as well. The question being like, how deep do you go?
Right.
But the concept being, allowing the ability to specify the depth.
Okay. Well, so we'll start off with Cypher. You're talking about the Cypher language. That's
Yes.
Cool. All right. So let's just say in our Pydantic, let's just create one that's like app.command, and we'll call it. Well, actually, let's try cursor. So let's try that. And so let's just start off with. Oh wait, we have to do this. Create a command that converts unstructured text into the Cypher language. All right. Cool. So let's give this a shot. Because we got to break it down into pieces, right? So, Cypher language. Okay, it's a little redundant, but let's just give it a shot. And it's with a Y, right?
Yes, that's with the Y.
So it chose a cipher. I mean, that is literally what we wanted. So we need to just change it a little bit. Cipher. Got some like Zodiac killer shit going on down there. All right. Okay. So here, nodes. Right? So it's some pretty interesting stuff, right? So I'll show you how I get better structured text from this. So we'll just grab this, and we will go to Sean's trusty custom GPTs. We go to the signature GPT and say, can you convert this into a signature that can reliably convert unstructured text into cipher? So we'll start off here with this. So first we have our DSPy signature. So we're no longer same pattern, but we're now using a class DT this, and then we're going to change this back to the predictor because we want to see the simplest way we can get this job done. So now that we have a signature, let's see what the signature does. Okay.
Oh, is it a...
Oh, it's still... Okay, yeah, there he is. So, yeah. There we go. All right. Oh, and... Okay, so... So that's what it looks like when we just do a predict.
Right.
And then this is what it looks like when we do a chain of thought. So another thing about the reason why I do, and this looks way better, the reason why I do CLIs is now anybody else that has access to PyPI if we were to publish this, well, I think we can. I have to fuck around with my keys. But basically, anybody that has access to PyPI and has the Olama set up and stuff like that could now use our application, our CLI, right?
Right.
So that's the thing is now we've taken it so that not only is DSPy usable in Python, DSPy can be used by anything. So we can change it, we can extract the text, but now we're still working on, I mean, this is pretty good, right? Like this is definitely a start towards something of value, right? So
yeah, this was about where I got, but the problem I bumped into was like iteratively attempting, like I know how I would approach the concept in just about any other language, or in several other like frameworks, for example, but specifically in DSPy, I bumped into a wall where I could figure out how would someone best iterate and improve improve like breaking down and adding additional cipher statements.
Well, what we can do,
that's why I bumped into a wall.
Yeah, well, for instance, one of the things that we could do is have a number in here, the maximum number of statements and stuff like that. But actually, let's just do something where we have a structure. We could do like a structured output, or actually, let's do this. This is where I get kind of thing. So we're gonna actually change this back to be. We're going to give it what we currently have here, and we're going to do this. We're going to say first we're going to get it to give us a voice command. Can you create a pydantic representation of the cipher language? Oops, that's not it. I don't know why it behaves this way now all of a sudden, but it helps me in terms of
I'd be doing the same thing.
it helps me learn how to type without seeing what I'm typing. Okay, we have cipher conversion. Okay, so it. Oh, okay. So let's take it from a different direction. Can you create a pydantic representation of the cipher query language? So this is how I would think about it. Cool. And so then here's something that we can do that's pretty cool is here. Can you create a function that exports the pydantic model into valid cipher? Because then we can kind of do like a interpolation.
Right.
Okay, so I think match is a keyword. Isn't match a valid keyword in Python? Should we use something else? Perfect. All right, cool. Now the problem is the JSON for this is going to be massive, but like this will be pretty cool. So how I'd approach this then is we can just go here to here and we can just create this is where I have in Pydantic. So then now we can have a modules folder, right? And we can just call this the cipher module, and this can become a DSPy module. So we're just building up from here. So we can reformat the file. We create our main. So I actually have a command that makes it, that pops it out. Okay, so we take query to cipher, print the query to cipher, and we'll just see if it works. Okay, cool. So what we can say now is I also need a function that can take a valid cipher string and convert it to the pydantic models. Because we need ingress and egress.
Right.
Okay. So we can do, oh yeah, so this has the to and from right in it. So let's see if it works. Perfect. Now we have our to and from. So,
Nice.
so already I think we're ahead of the game because now we can let's now pipe this back into our example. So what we can do is we can take this and we can go back to our Cypher module, and we can do class Cypher module DSPy. Def forward and we'll just keep it super simple. We'll just say text and we'll go grab our signature. I'm just closing files now. All right. Let's fix this up. Grab this, post this. Main. Let's just now we have so here's a pattern that I created. I called where I call it a call function. So this is how you turn an object-oriented pattern into a functional pattern. So I say def Cypher call, and then I say text string, and then we do this, and then we say mod equals Cypher module, return module forward text, and then we say Cypher print, and we just change this to be text. This. All right. Oh, we have these in here, so that's what was printing. So we can blank these out, and okay, we go to here. All right, cool. So that's our Cypher. So let's then take this alone and see if we can parse this. So now we're going to just blank this out for right now. And so we're not even worrying about the result from the language model. We're just going to call it sci text equals 3. And there we go. Right? So we just want to see if this parses out properly. So we can just take our Cypher query here, and actually we can just make this the Cypher string, and then we parse the query, print parse query there. We can see if it breaks. Okay, attribute has no, so let's do this. And then we'll just give it the error. Oh, and actually, let's see if there's a Cypher parser. Python, so I just pi, and let's just see what it has. Cypher. Cypher statement builder. So this is just like how I do like my research is I just see what people have done.
Mm-hmm.
So yeah, Neo4j, I know that name. Okay, we got llama index, which is interesting. This is interesting. Okay, and then one thing I do before we check, and I think I'm gonna have to go soon. Let's do Pydantic. Okay, there's nothing there. Okay, that's not good enough. Sorry. Nope. Rewrites. Subgraph. No. Pythonic language extension. Okay, so this is pretty interesting. So what we can do is watch this. Because I'm kind of lazy. We can do this. And say, use this instead of the regular expressions. So wait, I think it's building it. It's so import. So what you do when you're doing this, just so you guys know how I would do it, is I look for the code where it does the import. We can go back up to here. So what we do is we go down in simple. Okay, import query builder. So what we do is we go to here. And you saw how it uses the triple. So one of the things that I look for is people do kind of a lot of these things many different ways, but watch how I look at this. So we print the cipher call, watch how I see it represented. Because like people do all kinds of like hyphens and stuff like that, but look at how it represents it, right? This is the representation as if it was in Markdown. So you're going to watch what I'm going to do here. So use this instead of regular expressions. So what I'm going to do is I'm going to go under 3. I'm going to say Python. So you see how I do this? And then now it should okay. So this is good, but still, does it parse? So I guess this is for building queries. Creating cipher queries in Python rather than query. Okay, reusing them. Okay, so it looks like it's only for writing them. Declaration.
Not for taking them and converting them.
Yeah, let's see if we can find the repository. So this is one of the things I recommend to people is even if you don't know the language very well, just try looking at how they wrote it because you'll learn things. And so we see like the query is structured this way. So they're using typing, okay. Case when, okay. So there's a lot to this. And so what I would do if this was like my job is I would use this to create a parser. Now there's a lot to it. So, it's easier said than done. But using this to kind of, but just so you saw how the process worked, right? I started off by saying, let's create a Pydantic representation of it. And then let's start doing something that can import them. And it didn't do a very great job. But then we said like, oh, let's find something somebody did. And then, this could probably be used somehow to create a parser for this if we needed it. So to me, it's more of, so this is, then let's now take it before we end the video to my agent framework. The reason why I did it this way is that for instance, while parsing, you could have an agent that you use. So like this coder agent here, right? So you could have like a parser agent that has these finite states. Oh, actually, wait. See? Okay, here we go. So watch this. We're going to take this and we're going to say, instead of a coding agent, create an agent that composes cipher queries. Like, I don't even know what that means, but let's see what it thinks about, how it thinks about this. Okay, so here it's not doing it literally, but like this is where you would add it, right? And so this is the agent model, or however you want, the finite state machine way, and that the finite state machine, this prompt is how you can use it to walk through it, right?
Yeah.
So then now now create another agent that is the reverse of this agent. And so this is how I see these things being done in the future. Because in reality, I got this from the book, The Pragmatic Programmer, right? And so if you go to the chapter on, or topic, I don't know how they phrase it, on finite state machines, which is called something about like in the real world. Just a second, guys. Juggling the real world. 137. Okay, so what they talk about is using finite state machines for like parsing and all kinds of different stuff. So that's where the agent, and so what I mean by agent is an agent is able to determine what to do next based on unstructured text, right? Using a language model. So the work is actually very kind of, once you get this right, you don't have to do it again. And it is like, there is a lot to it, but let's just imagine that you were able to successfully create an agent that could walk through, right? You could then say, okay, so then you would do this. You'd say, now create a swarm of agents that are able to compose and decompose entire passages of text into a set level of depth of cipher queries. Cool. And so this is what I mean by a frozen swarm, is in reality, you don't need like all of the agents to be thinking about what to do and all this stuff. In reality, once you figure out what you want, like your certain level of depth or anything like that, then it's probably pretty clear. I'm going to share this link. I'm going to take this dog to the park. I think this is a good place to stop, but I'm going to share this in the chat. And I think it's a good starting point. Like, I know we're still, that's the thing, is like right now we're still in the GPT-4 phase where like it's not that good. For instance, it forgot to do my state changes and stuff. But I believe, within a couple months when GPT-5 comes out, it'll be able to follow what I'm doing exactly. That's my guess. Or be much, much closer, right? So it's, some of this is just a matter of like, it's going to take a couple months for us to get there. But, the techniques that I'm showing to kind of wrap this video up is that, using CLIs, expose the world to your functionality, having your CLI be able to create other commands using templates, right? This templating pattern goes across all programming languages and goes across all types of text generation tasks, right? I don't need the language model to figure out how to write a typer command. Just do it this one way every single time, and then we can. If you look at the history, right? History of what I've done, you can see that you can have the AI do these subcommands. So this is where the expansion in my mind comes from, right? Is all we have to do now is get it so that the AI knows how to do these things. And again, we just use these state machines where we have, a state swarm of agents that know how to make CLIs, right? So what you guys actually don't know that I'm doing is this is the prototyping for the bullwhip system. So you take the pattern I'm showing you, and you extend it all the way out to all SaaS software, which if you look at what I have in DSPyGen already, which is these templates, right? So HiGen is a template that is used in JavaScript, but like this is what I mean by like generating all software for all companies, is that SaaS software is actually not that complex. Like the patterns can't get too complex because humans have to use them in the first place. So in reality, there's only n number of patterns. So that's the thing, is that when you look at it, code generation as a problem of I need the language model to generate every single line of code, you all of a sudden see this like impossible problem to solve, and you need hyper advanced language models to solve these problems. But when you look at code from the opposite side of what's the functionality needed, what does somebody need to do, and let's not build software. So one of the things is that people now are building software to please people, right? To end real quick, to go with my philosophy of how I'm building the Chatman GPT, right? I'm not building this to please anybody, right? I'm not building this to trick users into clicking things. I'm not building it for that reason. I'm building it so that it does as quickly as you can, do what you need it to do, and then you move on with your life, right? But the whole appeal of modern, what was it? Let's look at LangChain, right? A perfect example, right? To me, I'm like trying to do things as simple as possible, get the job done. But look at the LangChain site, right? Like this is doing so much, and it's not adding this swirly thing is not adding value. It's just visual noise. But what they're trying to do is they're of the mind of like, we're trying to drag you into paying for our stuff. So, you have to do this appealing UI and, all this usability testing type stuff, and right, like all these patterns, because those are the modern standards. But I'm saying, no, let's just make it old school style and be done with it, and you do what you do and you're done. Also, an AI agent can navigate through this much easier than, so that's another thing that people don't really think about, that I think about all the time, is that a language model or an agent could walk through this, see what's happening, check this link, right? Read through all of the code, right? Let's look at the code, inspect it, right? And this is a perfect example of how to look at it, right? Is if we look at this code, and you strip out the data V's or whatever, it's very easy to look at, right? To figure out what's going on in my system, right? Like imagine this is how a AI spider is crawling through these, trying to figure out what to do. So let's do that same spider technique with the LangChain pricing page, which is like super distracting anyway. So let's try to figure out what's going on. So you got your pricing component, header, div, padding, section, right? This is why when people talk about being able to navigate code with spiders and stuff, it's like difficult. It's because there's so much stuff going on in here that's not actually relevant to actually getting work done. So that's just my philosophy. I might be completely wrong, but time will tell. So time to take this dog to the park, and I will see you guys. I might be doing some more code later, but this is round 2.